Hey, hello, geometry friends. Here we are. We're on to chapter 2.2, conditional statements. So we talked about in 2.1 inductive reasoning, and now we're going to go into kind of the ability to write logical or logic-based statements. And so we're going to learn these things called conditional statements and some variations of that today. So let's get right into the definitions, and then we'll have some questions. Okay, a conditional statement. So a conditional statement is written in the form of if P, then Q. And so what that means is, I'm going to use a consistent example through all the definitions, but it's basically saying if this first P thing is true, then this Q thing is a conclusion that you can be sure of. So for example, if, and there'll be a lot of writing in this video, so bear with me and my penmanship. If you are taking geometry, beautiful looking, then Mr. Mefford, is your teacher. Now, obviously, I could force me to be more and more specific because you think, well, what if I'm in another school or something like that? But you kind of have to sit within the realm of reason whenever you're making these statements, not be too imaginative. But so if you're taking geometry, then Mr. Mefford is your teacher. The P portion of that is the part that comes after the if. So P is if you are in geometry, then Q is your conclusion. Mr. Mefford is your teacher. And so this is how you can learn to reason for taking from one set of facts or one set of conditions then to the conclusions that would follow. So that's known as a conditional statement. It's conditionally true if the first part is met. So let's keep looking at the different parts of that in our next definition. So the hypothesis. The hypothesis is the P part of a condition. It's followed by the if. So it's kind of like what the loaded, kind of like loading the weapon or loading the bow, stringing the arrow, because that is the first part that you have to set up. In our case, it is if you are taking geometry. So it's usually the first part, but don't get fooled by that. It's the first condition that has to be met. This is the P, and again, it's known as the hypothesis. Okay, whereas the second part, the Q, so actually I should go ahead and put that as, I'm going to put that as our notes. This is the P. The hypothesis is always shown by the letter P. And actually that reminds me, let's go back up to here, kind of the way, the formatting way in which a conditional statement is written as such, P arrow Q. And if you see that notation, that is basically saying if P, then Q. If you're taking geometry, then Mr. Mefford is your teacher. Another way in which this can be written is a Venn diagram. And what that means is that you have a little circle, and that is your hypothesis, which if that is true, then it lies within a larger circle of Q. So those are both ways in which you can notate a conditional statement, either with just the arrow notation, P to Q, or with a Venn diagram. And we'll do one of these like in the exercises. But if P is true, then it's part of the larger grouping of Q in the outer circle. So if I were to write that with this, in the middle circle, I would write taking geometry. And the outer circle would mean that, well, then that means Mr. Mefford is your teacher, because anyone taking geometry has Mr. Mefford, at least at CCS, as their teacher. So those are two ways of notating the conditional. And again, the hypothesis is the P portion. The Q portion is the conclusion. Okay, then Mr. Mefford is your teacher. And for your examples, you can use this one or you can make up your own. But it's kind of nice to be consistent because you can see how it works throughout all the different definitions. Okay, and so that is the Q part that comes true. All right, so a conditional statement made up of a hypothesis and a conclusion. Then we have the truth value. Truth value, just a fancy way of saying, is it actually true? Is your conditional statement true or false? If you state the P, does Q necessarily follow? So for example, we could look at the one we're using. If you are a geometry student, then Mr. Mefford is your teacher. We could, based on what we know of the school and the classes that are being taught, the number of teachers teaching those classes, the statement we're using as our example has a true value. During the exercise, you'll come across various conditional statements that aren't true, and you'd say, no, that's false. And it would be the same way as we talked about in chapter 1, is how do you prove a conjecture false? One thing to note here is they're proven false by a counterexample. For example, if you were, say, you were in Mr. Ambrose's class and he was teaching you independent study geometry, that's not going on. But if that was true, you could state that Mr. Ambrose is my teacher and I'm taking geometry. Well, then that is the counterexample you would need to prove the conditional statement false. So that's how you determine if something has a truth value of false. You need to have a counterexample you can supply. The other thing that I want to note is the second part right here, and that is it's false if the hypothesis is true and the conclusion is false. But it must be that the hypothesis is true. So let me give you an example. If we're going with the one that I've stated so far in this video, if you're taking geometry, then Mr. Mefford is your teacher. If you were to get a statement that said, you are not in geometry, does this imply that our conditional statement is false? We're saying, well, you're not in geometry, so therefore Mr. Mefford's not your teacher. No, because notice it's denying even the hypothesis. So you can only prove a conditional statement false if the hypothesis is true. If they start right off to saying you're not in geometry, well, then we're not even talking about, you're not even starting the thought correctly. So it can only be if I'm in geometry, then Mr. Ambrose is my teacher. That would be a proper counterexample, but it's not a proper example. And so maybe I'll just go ahead and put some blue crosses through here to deny the hypothesis. You can only prove a statement. You're going to find there's some trick questions this chapter and this chapter and lesson on that. If they don't give you the true hypothesis, then you can't say whether the conditional statement's true or false. Okay, it might be a little confusing, but okay, rewatch that if you're not sure. Converse. So now we have variations on the conditional statement. We have 3 of those called the converse, the inverse, and the contrapositive. A converse is if you just take P and Q and you switch them. So we could notate that quickly as such. Q, if Q, then P. Okay, if Q, I'm going to even write that out. If Q, then P. Okay, so it switches them. And so, for example, take out the one we're using. If Mr. Mefford is your teacher, now I'm taking what I concluded in the last statement, then you are in geometry. All right, it takes me a while to write. So first of all, to note, if they want you to write the converse, just write it. You don't necessarily have to worry, well, is it true or not? They just want to see, can you reverse the 2 statements? Then with anything, you can go ahead and decide, well, what's the truth value of this? Is there a counterexample? Or is this also true? I would use just to practice finding the truth value. The good counterexample would be, I think it's Chloe and some of you others. Maybe it's just Chloe. But no, I think somebody else. Sorry, I'm forgetting. But no, you have me for history. So in other words, if Mr. Mefford is your teacher, then you're in geometry. No, I'm in history. With Mr. Mefford. This would be a counterexample showing that the truth value of this particular converse is false. Because Mr. Mefford is my teacher, but he's my teacher for history. So that's an example of a counterexample that could prove it false. And that a lot of times you'll find that. You could have a true conditional statement, but if once you reverse it to the converse, it's no longer true, and you can find a counterexample. Okay, so that's a converse. Next is an inverse. An inverse is where you leave P and Q the same, but you negate them. In other words, you kind of put the word not in front of them. And the way they notate that, first of all, is if not P, then not Q. And they put that little squiggle there to mean not, or the negation of it. And so what that would look like, or the one we're using, would be if you are not taking geometry. Notice we're back at the initial conditional statement. We're not dealing with the converse at this time. We're back with the normal P and Q. If you are not taking geometry, there's the squiggle, the negation, then Mr. Mefford is not your teacher. So you negate both. Again, just practice writing it, and later you can decide, does this have a truth value of true or false? But again, just take your P, take your Q, and negate them. And if one of them is already negative from the initial conditional, then you would just remove the negative and do the opposite. If it's wintertime, then it's not spring. Well, then you would change. If it is not wintertime, then it is spring. Kind of, I can't remember what I said, but you get it. Just switch it on whatever it is the first time. If we looked at the truth value of this, you would see that this is also false. If you are not taking geometry, then Mr. Mefford is not your teacher. Well, the same counterexample we used above would still prove it false because I'm in history, and which is not geometry, but Mr. Mefford is my teacher for history. So one thing to note is actually inverses and converses tend to have the same truth value. If the converse is true, the inverse will be true. If the converse is false, the inverse will also be false most of the time, or maybe even all the time. But I'm careful about saying it absolutely. Okay, and then contrapositive is if we marry those two things together. That is if we converse and inverse at the same time, which means if not Q, then not P. Okay, so now you're negating and switching. And so for the example we've been looking at so far, it would be if Mr. Mefford, because that was the initial conclusion, but we're also going to negate it. If Mr. Mefford is not your teacher, then you are, we're going to not this also, not in geometry. So again, we switched the P and the Q, and we negated both. And if you think about this one, if Mr. Mefford is not your teacher, then you're not in geometry. That's true, because I'm the only teacher of geometry at the school. So if I'm not your teacher, then you must not be taking a geometry class. So I want to point out there, notice the contrapositive has the same equivalency as the initial conditional way up here at the top. Okay, so if a conditional is true, your contrapositive will be true, whereas then inverses and converses tend to match up there. Obviously, we might want to start beginning already, telling these three apart: contrapositive, inverse, and converse. They all sound very similar. You're going to want to spend time writing them out and practicing, and maybe taking the quizzes online, but to make sure you can begin to tell these two apart. Switching them, converse. Inverse, think of it almost like flipping it over, making them both negative, and the contrapositive is both flip and switch. Flip and switch. Okay, so let's go ahead and get to the questions. Move this here so I can see. Okay, questions. What is the symbolic form of a conditional and its converse? Well, we've already done a lot of this, so let's see how fast we can get through these questions. So the conditional, the symbolic form would simply be if P, then Q. And that's how you would read it, if P, then Q. The converse, I'll go and change colors here. The converse would be if Q, then P. And I only asked you in that question for those two. We could do all four, but we'll just start with those two. That's a symbolic form. And again, there is the Venn diagram. Oh, that's what we're going to do number two. So number two asks, create a conditional as a Venn diagram. Well, let's just go ahead and stick with the one we've been doing, just so that you can see it in all its different forms. If you are taking geometry, then Mr. Mefford is your teacher. So we would put taking geometry in the middle. Again, you can be using whichever one you want. I'll abbreviate. Taking geometry, not geography. Then Mr. Mefford, we'll just say Mr. Mefford is your teacher. Okay, so that means that if you're in this circle here, then you are encompassed in the category of Mr. Mefford being your teacher. So that's what the conditional is, by showing you that anything in the little circle is also in the bigger circle. So if you're in this geometry circle, then you're inside the circle of Mr. Mefford being your teacher. You're very lucky. You're very lucky. You're very blessed to have me as your teacher, don't you think? All right. So now number 3. So that's a Venn diagram. Number 3, and let me just, so in other words, this is your P, and then this is your Q out here. All right, number 3 says, write a conditional with a false converse. Well, we already did the one that we've been doing. If you're in geometry, then Mr. Mefford is your teacher. That's true. The converse would be if Mr. Mefford is your teacher, then you're in geometry. No, that's not necessarily true, because I could have a student who's in my history class, but he's not in my geometry class. So that's not true. We can just go ahead and think of another one. Simple one would be something like if the animal has 4 legs. I'm sorry, I'm going to reverse that. It'll be wrong right away. If, do it this way. If it is a dog, then it is an animal with 4 legs. Okay, and this is where, again, you don't want to be cute. You're like, well, I've seen a 3-legged dog. No, that's not the natural course of things. That's, of course, that doesn't prove this false necessarily. We're thinking on the normal course of events. So we would say this is true. If it's a dog, dogs have 4 legs. There's no species of dog that doesn't have 4 legs, and so this is true. The converse then, and again, here would be my P, and then the then marks my Q. Now I would go ahead and switch those here and say, again, a lot of writing in this assignment, but you would say, if it is an animal, and I take that whole clause, an animal with 4 legs, then it is a dog. And so that's successfully switched, where now I have my Q right here and my P is here. But is this false? Yes. Can you give me a counterexample? If it is an animal with 4 legs, there you go. I'm sure you can think of many. Elephant, cat, okay, hyena, why not? Even though that's kind of close to a dog, but we'll pick something less obvious. But anyway, elephant, cat, those would all be counterexamples showing that this conditional statement is true, but the converse is false. Okay, now comes a little trickier. Number 4, write a conditional with a true converse. So it's got to be true forwards and backwards. Let's see what we can come up with. Here we go. I got one. If, let's stick with the animals, because who doesn't like cute animals? If it meows, then, and let me put that down there. Then, sometimes it's nice to stack it and just only put the hypothesis on top and the conclusion underneath it. Clearly separate the two. If it meows, then it is a cat. Okay, so there's my P is if it meows, my conclusion is then it's a cat. Let's go ahead and switch those and say if it is a cat, then it meows. Okay, so we've switched our P and our Q, and yet you can see it's actually true both ways. If it meows, cats, obviously there's cats, they're silent or they lose their voice or something. But again, those aren't the exceptions we're looking for in the natural course of events. If it meows, then that's a cat. And if it's a cat, then all cats meow. And you could put house cat if you're getting into tigers and different things like that. But, don't annoy yourself too much. So you can see this is what an example where both the conditional and the converse are both true. And we'll talk about in chapter 3 what that means. But it basically means we're getting close to having what's called a definition. because both of those are true. All right, number 5, last one. Write the converse, inverse, and contrapositive of the statement. Notice I had animals on the brain when I wrote this. If an animal is a cat, then it has 4 paws, and then find the truth value of each. Okay, let's go ahead and work through this. Let's go ahead and start with, okay, so here's the conditional statement. If, I'm just going to put it to save space. If it is a cat, then it has 4 paws. Okay, true or false? We're going to say again, because there aren't 3-legged species or 2-legged species or 5-legged species. We're going to say, okay, so that's true. I can't think of a counterexample of something that's a cat that doesn't have 4 paws under, again, normal circumstances. Okay, so now let's go ahead and do our, so this is our conditional. Let's go ahead and do our converse. Just switch them. If it has 4 paws, then, oh, don't get too sloppy, sorry. Then it is a cat. Alrighty, 4 paws, then it's a cat. No, I can think of a counterexample being, let's just keep it simple. How about a dog? Dogs have paws. You could also say a bear. Bears have paws. So dog is a counterexample, false. And so if you think something's false, you just supply yourself with a simple counterexample. Okay, let's do the inverse. So the inverse is where we negate the condition, the hypothesis, and the conclusion. Whoops, sorry. All right, so inverse would be if it is not a cat, then it does not have 4 paws. Okay, so note this is the same order as the conditional, but now we've negated both sides. Ask yourself if it's true. If you remember, I said the converse and the inverse are typically the same. Same idea. If it's not a cat, then it doesn't have, no, I can use my same exact counterexample, dog. Okay, because a dog is not a cat, but it does have 4 paws. So this is still false. Okay, because a dog is not a cat, it meets the first requirement of the hypothesis, but it has 4 paws, so false. And now let's get last one, contrapositive. Okay, contra. This is where we're going to reverse and do the converse, but we're also going to negate it at the same time. So if it does not have 4 paws, then it is not a cat. Okay, so notice we switched them. There was both a switch of P and Q, and there was the negation. So we asked this if it's true. It does not. If it does not have 4 paws, then it's not a cat. Notice, like I said, contrapositives go with the conditional statement. This is true because all cats have 4 paws, and so that would be, in fact, true. If it does not have 4 paws, then it could not be a cat. Okay, mutants and poor accident-ridden kitties aside. Alrighty, no, that's a bit long, but hopefully you enjoy it. Hopefully it makes sense. It's kind of fun to reason your way and make up some of your own. So we'll see you on the video of the exercises if you need additional help. All right.